Hi, I'm Jonathan Turner, and today I'm going to teach you about the Bernoulli Principle. To begin with, Daniel Bernoulli was born on February 8th, 1700, in Groningen, Netherlands. Daniel's brothers and his father were also mathematicians, so one could say that it kind of ran in the family. And in addition, his father, Johann Bernoulli, was also a doctor and a mathematician. So he was known as the Archimedes of his age. And if you didn't know, he was a Greek mathematician regarded as one of the greatest mathematicians of all time. So obviously, his father held a very high status in the community. So his father forced him to become a doctor, but naturally, David had a burning desire to pursue a career in math. All right, so after briefly pursuing a career in the medical field, he realized he could not abandon his passion for math. So he began to do experiments. He believed that he could use mathematics to reveal the secrets of the universe. So he carried out fluid experiments in which he measured water flowing out of vessels. He was able to institute a mathematical relation in which he depicted the correlation between the water height, the water pressure, and the velocity the water came out as. He observed that water flowed out of vessels quicker when the water height was increased. And also his father researched potential to kinetic energy conversion. So he made a strong point to take the viewpoint of trying to observe his experiments from that take. In 1724, he actually published a book, Mathematical Exercises, and he made his contributions to fluid mechanics, probability theory, geometry, and differential equations. So he applied what he'd learned and applied them to his father's idea of the conservation of energy. And in this, he created the Bernoulli Principle. So what is the Bernoulli Principle? The Bernoulli Principle states that when a fluid's speed increases through a region, then its pressure will fall. So basically, if a fluid's moving fast through a region, it has lower pressure. If it moves slow through a region, then it has higher pressure. So it does say fluid, and I know that makes you think of liquids, but it also applies to air. And he was also able to describe it correctly in a mathematical way. So what are some ways that you can apply the Bernoulli Principle to your everyday life? One you can carry out yourself, even at your home, with a hairdryer and a ping pong ball. So watch as I turn it on with the ping pong ball up. So as you can see, it doesn't come out because the column of air keeps it up. Now watch as I change the angle of the hairdryer. This. So why does the ping pong ball stay up, you may wonder? Well, first you noticed vertically, the ping pong ball moved up and down until it reached a state equilibrium where it just kind of stayed in place. But what keeps the ball floating is actually air pressure. The air around it is moving faster than the air beneath it. So that keeps it in the low pressure column of air coming up from the middle because of the higher air pressure surrounding it. So I know that isn't applicable to daily life that much, but that's one cool way that you can observe it for yourself. But some things that you may notice in your life is a curveball. The entire pitch works purely because of the Bernoulli Principle. Since the baseball stitches won't curve, right here, it's crucial that the pitcher grips them to, get a better grip. But when he throws it, this causes a thin layer of air to engulf the ball. And the air pressure becomes higher on top of the ball than on the bottom. So therefore, the Bernoulli principle explains that less speed should be on top of the ball in contrast to the bottom, and that causes it to have a spin and hopefully for the batter to miss the pitch. Another example, especially in these winter months, is a chimney. You know, if you're using a fire, this doesn't apply to gas logs, but it does apply to wood fires. So, have you ever wondered why that fires are usually better on windy days than on not windy days? Well, the Bernoulli principle can explain that as well. When the wind's blowing above the chimney, it causes there to be low air pressure at the top and higher air pressure at the bottom. So this causes the air to rise up and making the fire better. And it pushes up the chimney. Have you ever sprayed someone with a garden hose before? When you put your thumb over the top of it, generally it comes out faster. Have you ever wondered why this is so? The Bernoulli principle can also explain this. The pressure inside the hose is much greater than the air outside the hose. Because the law of the conservation of mass, the mass flow rate inside must equal that of outside the hose. So, to conserve kinetic energy, because of your thumb covering the nozzle, the water must gain velocity, squirting out at a faster rate. So, these are a few ways that you can apply the Bernoulli principle to your daily lives. And thank you for your time, and goodbye.